the latest version of Informix. And some really exciting stuff here on Informix HQ and backup from RSS secondaries. Before we, Carlton, get started, I want to remind you that the IIUG is going to have a conference in October. This is in lieu of a conference where we can all attend in person. This is going to be a virtual conference. And it's going to be 3 days of technical sessions, keynotes, and tutorials. And one of the key things is there's a new Informix certification badge. To get certified, you have to take the test, but the conference is going to have a lot of background and prep work to help you with that. And part of your registration fee for the conference will include taking the test. So watch out for more information. If you're not a member of the IIUG, you should join. Please go to iiug.org and sign up. And thank you, Carlton. Take it away.
Okay, one thing that I'd like to ask you to do is if you have questions, use the chat option in the WebEx. There should be a little side window you can open. Send your questions to all participants. Lester will triage some of those and help me find them if I can't. We do have members of the HCL development team on the line with us right now. They may also respond to those questions as well. And thank you to them for all their hard work and what they did in bringing out this XE6 webcast. As Lester mentioned, today I'm going to be focusing on IHQ and backup from RS secondaries. There's some really powerful technology here. There's some things that I'm very excited about. So without any further ado, let's jump into it. XE6 brings out IHQ version 1.5. Now in XE1, we had obviously version 1.1, and through the intervening fix packs, we've gone through to 1.2, 1.4, and now we're on 1.5. This is actually a cumulative discussion since XE2, what features were introduced between 1.2 and 1.5. If you've been using IHQ for a little while, some of these things may be old news to you because you've already seen them. So let's go ahead and get started with changes to the start and stop script. Version 1.2 introduced a shell script that made starting and stopping both the server and the agent components fairly easy. Instead of having to use a Java command line script, you could run this IHQ or Informix IHQ shell script that would take some parameters and then start either the agent or the server component for you. In version 1.4, there were numerous changes to the start and stop script, and I'm going to cover what those are now. First of all, in addition to a Windows and a C shell, which covers most of the Linuxes and Unixes, there is now a Korn shell version of this script specifically for AIX and its default Korn shell. There is also a help option that displays the new formats for the commands. So the command syntax remains the same, though the format of the commands have changed. They're now all lowercase, or the parameters are all now lowercase rather than mixed case. So that's a fairly significant change. Also, a very big change is that the ability to name a process. So for example, when you started the server or you started an agent, you could give that process a uniquely identifiable name so that you could look for it and kill it later on if you needed to. That ability to name a process has been withdrawn because AIX doesn't support process naming. Now we have a way of handling that, which you'll see in just a second, but just be aware that that parameter no longer exists in the command syntax. Another significant change is that you can rename both the jar and the property file names to almost anything you want them to be. So they can be very easily user identifiable and make sense to you. The one caveat is that the jar file name still must contain Informix HQ in it somewhere. So you could have my_Informix HQ.jar if you wanted, or Informix IHQ underscore something underscore something underscore something dot jar if you wanted to, as long as that text string is there. The property file names no longer have to have a .properties suffix to them. So you can name these files any way you would like. In version 1.2, there's some very specific restrictions on what these file names could be, and that's now been lifted. It is these properties file names that will be returned with the new list option that shows you what IHQ services are running so that you can identify the correct service to kill in just a moment. So here is an example of the list option. So you can see I have both a server and an agent process running and the name of the properties files for that process. Since I only have one server and one agent running on this machine, I use the default values of Informix IHQ dash either server or agent. But again, as I said, you could rename these files to anything that makes sense to you within the limits for the jar file. The default locale encoding for IHQ is still and will most likely always be UTF-8. Now that may or may not work for your instance environment. If your instances are not using UTF-8, make sure you use the encoding parameter and put in whatever the correct locale is for your instance and database environment. Just a quick note on starting IHQ. There is a new logging mechanism that's being used within IHQ, and I'll talk more about that towards the end of this presentation. Within that new logging mechanism, there is an XML configuration file, and you can see what the name of it is. It doesn't have to be in the directory where IHQ is, but we recommend that you leave it there. If that file does not exist, there are some startup messages that will appear. And you can see an example of these down below. They don't actually affect IHQ functionality. It's just a status message saying that the logging mechanism can't find its XML file. As I said, it does not affect IHQ functionality, so don't worry about them. Development is currently going through a process of figuring out how they can suppress these error messages if the XML file does not exist. The stop process has been changed and improved as well. As I said, we can no longer name what the process is, so you will have to use the process ID. What's nice is that this stop process actually validates that you're trying to stop an IHQ process and actually truthfully reports whether or not the process was stopped. Those of you who remember my webcast on XE4 functionality pointed out that there were some weaknesses within the start and stop script, and this was one of them. So when you run a list command, you will see that it lists the process ID along with the properties file for that process. You can see that there is a 5385 and a 5882. If you use the incorrect process ID, as you can see below, I'm using 5386. The utility or the stop utility does verify that the process is or is not an IHQ process. If it is not, it will abort and give you a rather nice error message that says basically try again. If you use the correct process ID, that process will be stopped and you will get an error or you'll get a confirmation message back. And again, you can verify that it is gone by using the list option. So that's the new start and stop scripts. There is now a new test connection that's available for the agent connection properties as well as the server connection properties. So you can see here that I'm trying to configure a server within an IHQ group. I list what the instance name is, the host name, the port number, along with the monitor and administration credentials within that instance that I want to use. At the bottom, there's this new test connection button. Once you filled in all this information, you can press that. And if something is wrong, you will get an intelligent error message back, not just connection could not be completed, good luck. So for example, if there is an incorrect server information, whether it's the server name or the port name, it will identify it as a server error. If there is an error in either the monitor or the administrative credentials, it will tell you which credential you're having a problem with so that you don't have to guess and try and figure it out through trial and error. So this is a nice little enhancement. If everything is working correctly, you get the green button that says everything is fine, and you can go ahead and save and persist those credentials. In addition, there is the ability to add specific connection properties for both the server and the agent. And this has been available for a little while. In the XE5 release with IHQ 1.5, the ability to set up agent properties configuration was moved into the agent setup page. But you can now use the same, with one button, you can now select to use the same properties as the server, or you can modify these properties as needed for that specific instance. Likewise, for the IHQ repository database for that particular agent, you could either use the one that's predefined within the server, or you can define a specific agent database for that particular agent. You can also add additional connection properties. For example, in this particular case, I'm setting up an SSL connection between the agent and the instance. And there are other connection properties that you can define as well, but that option is now available to you here underneath the Agent tab. In version 1.2, there were some significant enhancements to the IHQ Schema Manager component, and a lot of very good, useful information was added. In 1.5, there were some new cosmetic and functional enhancements that were made to the Schema Manager. For example, when you select a database, in earlier versions, you would get the information, the metadata about that database in a columnar format that required you to scroll up and down within the window. Now it's presented in a tabular format. So with one look, you can see everything that you would want to see. Again, it's a small enhancement, but it's nice. The IHQ people are paying attention to the feedback they're getting from the user community, thinking about the tool, figuring out how they can make it better, and they're delivering both small and big cosmetic and functional enhancements to make the tool even easier to use. Perhaps the biggest change is the new Create Table option. It is both fully featured and intelligent. And by that I mean, in terms of fully featured, you have options to create almost any type of table you would want with almost any type of characteristic to it, as you'll see in just a few minutes. And the process itself is intelligent. So you can be working through the process of creating a table, decide you need to make changes, back up in the process, and you'll find that all your earlier selections are saved, they're persisted. You don't have to restart all over again. You can make whatever change you need to earlier in the process, move forward and find all the steps after that. All that state has been saved as well, so you don't need to redo all your work. Again, it's a small thing, but it is a big thing in terms of usability. So hats off to the IHQ team for that. There's also context available help. So if you are hovering over a particular field, you will get help information for that particular field, oftentimes with what options are available to you. You can create standard, raw, or externally stored tables. When you decide or when you're ready to add columns, almost every single data type, at least built-in data type, is available for you to select. If you want to use specific user-defined types, that's not something I tested at this stage, but I would imagine that they would be available to you once they're registered in the instance. You can enforce check constraints as well as null and not null from this drop-down. You can also add constraints such as primary keys, foreign keys, check constraints, all with a click of a mouse button. And you'll see that there is an advanced table options button here at the bottom left-hand side. Within this option, you can select whether you want page or row lock mode, various add-ons to the table such as ver calls for updatable secondaries, ER keys, again, if you need to use enterprise replication or updatable secondaries, and other options, first extend size, next extend size, the index storage, whether you want it in table or you want to create fragmented indexes, those are all available to you from this menu. At any point, you can select to look at the SQL statement that's being generated to actually create the table. So you can ensure that what you've been pointing and clicking is what you really want to happen. And again, if you're not happy with what you see, you can move back and forth in the creation process to make the changes you need, and your state is saved at each step. There's also field level validation that occurs, or verification. So I created a My Test tab table in the My Stores database. So if I try to create another table with that same name, you immediately get an error that there is a problem. The utility doesn't wait until you walk all the way through to the end and you say commit to report back that what you've done is incorrect. So again, a very nice feature. You're immediately alerted when there's a problem so you can fix it right there. There is also a drop table option that's been added, I think is also very nice to have. And those are, I should say, the changes to the Schema Manager. An additional property that you can add to a connection is whether or not the SQL component of that connection returns the ISAM error in addition to just the SQLCA code. This is kind of a cheesy example. I know it's not giving you a tremendous amount of information, but it at least shows you what happens. So I created the My Test table in the My Stores database, but in this particular case, I'm connected to the IHQ repository database, and I'm trying to select from My Test tab. And so we get the SQLCA code that says, hey, the table's not in the database. If you add the append ISAM property to the connection, and you run an SQL statement, you will now get the ISAM error that corresponds with that error in addition to the SQLCA code. Like I said, this is kind of a cheesy example, but it shows you what will happen if you set the property. So again, there might be cases where you need the ISAM as well as SQLCA code, and now you can get it within IHQ. Finally, the last thing on IHQ is the incidents and incident reporting menu. There are a number of useful features here, including the ability to filter by instance, by a date and time range. The incidents themselves can be collated into groups so that you can look at them as groups rather than scattered throughout the incident report. You can acknowledge or dismiss incidents either by range or by group. And if there is a particular incident that is being reported again and again and again, IHQ will actually filter out the repetitive instances to reduce the clutter within this particular component of the tool. You can look at specific incidents themselves and dive down into greater detail if that's what you'd like to do. As I mentioned at the very beginning, the Java logging mechanism has been changed to this log4j2, and it's this new logging mechanism that's generating those XML configuration file errors when you use the start and stop script. Development's working on this, but just understand that if you do want to go in and look at the Java logging that's occurring, this is the utility that's being used, and you will have to parse through its files and output and use its utilities. Other than that, all the open source libraries within IHQ have been upgraded to the latest version, so they're all current. All potential vulnerabilities that the white source scan has triggered have been addressed, and in addition, there are other user-reported defects that have been addressed and included in this particular release. I do know that planning is underway for an XC7 release of Informix sometime towards the end of the year, and there are new enhancements to IHQ that are planned for that release as well as v.next. So again, the IHQ team is continuing to work and build a better mousetrap for us to use. And with that, I think I've covered everything within IHQ. We'll go ahead and continue. And this is probably why most of you are here. This is what I consider the big bang, well, that and ER, but the RS backups are what I consider to be the big bang feature in XC6. So let's talk about that. But before we go any further, time out, hold on, stop. I need to make a technical correction to something that I told you in the first webcast, and it has to do with the HA clusters. So let me retrieve the foot out of my mouth and tell you something that I should have mentioned the first time around. In the first webcast, I said that system changes need to occur, or that system changes are occurring in XC6 that require an outage to the HA cluster and ER clusters to upgrade. That is correct. There's specific guidance on how you need to restart ER, and that guidance has not changed. What has changed, or what I neglected to mention, and this is my error, is that you don't have to have a full HA cluster outage to upgrade to the next release. You know, I had said, oh, you have to shut down the entire cluster, do the upgrade, and then turn it back on, and that's not entirely correct. In XC4, 14.10, we introduced what's called the offline secondary conversion functionality. And that functionality can be leveraged in upgrading to XC6. So I apologize, I did not include that in the first webcast. So if you have an HA cluster and you're migrating to XC6, what do you need to do? Well, you can certainly follow my instructions in the first webcast, which basically said shut everything down, upgrade, turn on the primary, and move forward from there. Or you can leverage the offline secondary migration process. And this is what it would look like. So you would start by installing the XC6 binaries on all the servers in a separate directory. You'd upgrade all the configuration files and so forth so that you can easily just switch over to that new directory when you're ready. If you have SLAs through the connection manager, if those SLAs are only pointing at the primary, you will want to update those so they point at the primary and the secondaries. Because at some point, you're going to see in just a second, the primary will go away. And with the offline secondary conversion, there is a way that we can have partial cluster functionality during this upgrade process. So if you have SLAs, update those. Turn off the failover control if it's enabled, so that when we do turn off the primary, there isn't a failover to one of your backups. So once all of those infrastructure changes have been made, you do need to turn off the cluster primary. Now, when this happens, the secondaries can still continue to process queries, but they will not be able to process DML operations. So if you've updated your SLA, your applications, particularly your read-only applications, will fail over to your secondaries and continue processing work there. So your reports can continue and other operations can continue. On the primary, you'll flip your path to point to the XC6 binary. You'll restart the instance, you'll let it upgrade, and it will come online. The secondaries will not connect to this new primary because of the control flags we have with the rolling upgrade. But the primary will begin processing transactions. Now, if all your SLAs are pointing, we're normally just pointing at the primary, you can reset all those SLAs at this moment in time, and then your applications will take off and keep working. Otherwise, leave the SLAs where they are, and then one at a time, turn off each secondary instance, update the paths, restart the secondary, let it upgrade. And once it upgrades, it will automatically reconnect back to the primary. Once all your secondaries are reconnected, reset failover control and the SLAs and so forth. Using this offline secondary conversion, you can at least have partial cluster functionality while you're doing the upgrade. So again, I apologize, I did not include that in the first webcast. Backup from RS. The ability to back up an HA cluster from a node other than the primary has been a request that goes back probably decades. With XC6, it is now possible from an RS secondary. Well, why an RS secondary versus an HDR secondary? Because it was easier on the RS secondary. Does that mean it couldn't be on an HDR secondary? No, it does not mean that. And who knows, it may come soon. But for the moment, it's just on the RS secondary. There are two use cases for this technology, two different modes is what I call them. And depending on what mode you're going to be using, there are different configurations that you will need, different configuration parameter changes that you'll need to make, and different operations that you'll need to execute. Option number one is what I call the cluster mode, which means you are going to use the RS secondary for your primary backup and restore operations. So both the instance and the logical logs will be backed up from the RS secondary, and it becomes your one and only backup option, if you will. Then there's also what I call a localized backup, and this is a backup to your backup. This is a backup from the RS secondary that is in addition to and supplements the backup that is occurring on your primary. Why would you want to do this? Well, you have your main cluster backup being stored in this location and on these servers or these files, and you can have a bunker backup that's stored someplace else. Or you might need to create an additional secondary or want to have an additional standalone node, and the transfer of information between the primary backup location and wherever your target is too long, or it would take too long to execute. You can create a localized backup closer to the target and get it up and running quicker. Those are just two of the use cases that you might want to use for this. Both on-tape and on-bar backups are supported with this technology. Backups can occur on RS secondaries with or without updatable secondary being enabled. That said, development does have some very specific guidance on this, and they strongly recommend, if you're doing a cluster backup, that you enable updatable secondary, because that's the process that will enable us to update and use the on-SM-Sync utility to synchronize the sysutils databases and the boot file between the RS secondary and the primary. So this is very important. Backups on RS secondaries configured with delayed apply can occur as well, though my personal guidance on this is do not do it. The backup process when delayed apply is enabled, the best way I can describe it is extremely funky. And it's not something that you want to get involved with, so just please don't. Just save yourself a bunch of grief, okay? So how do you enable RS backups? There is a new configuration parameter called barsec allow backup. It is not included in the onConfig file, and it is not dynamically tunable. So you will need to restart the RS secondary if you intend on enabling this. There are three values for this configuration parameter. The default is 0, that RS backups are disabled. Value 1 gives you the local backup, so that there are no updates to the sysutils database when you run on-bar operations. 2 enables what is known as, or what I call, the cluster backup option, and the sysutils database is updated for on-bar operations, as you'll see in a couple of moments. The sysutils database itself was not intended for multi-user use. It was not intended to support multiple concurrent sessions. So we strongly discourage having more than one on-bar process updating sysutils. Doing so could lead to corruption. Do not set barsec allow backups to 2, which gives you cluster mode, and still run on-bar backups on the primary as well as the secondary. Pick one, stick with it. Let Informix handle any of the changes that need to occur to this. Art is telling me now that this parameter is now on the XC6 release version. I was using the pre-release version, so I guess it is now in the onConfig file. Thank you, Art, for that. Are RS licenses required to take a backup? No, they are not. You do not have to fully license the RS secondary in order to create a backup. Executing RS backups will have an impact on your logical log backup device. If you are executing these backups in local mode, so barsec allow backup is set to 1, the logical log backup device on the primary remains unchanged, so that log backups are triggered and will execute on that primary when logical logs are filled up. The LTAPE device on the RS secondaries are still set to dev null since they aren't being used. So that's the information on LTAPE dev for local mode. If you are using cluster mode, so barsec allow is equal to 2, ltape dev on the primary or and on the HDR are now set to dev null since they aren't used. But ltape dev on the RS secondary must be set to a valid value so that full logical log messages trigger the backup of the logical log from that RS secondary. Executing backups on the RS secondary also has an impact on the ability to have non-logged objects in your instance or database. So if you are trying to execute RS backups, they will be blocked if you have a non-logged smart lob space. If you have a raw table inside of a logged database, or you have a non-logged database in the instance, or even a non-logged slob, even if it's in a logged smart large object space. You may be saying, but wait a second, I thought to use the HA cluster, everything had to be logged. And that's not true. You can have non-logged slobs and non-logged smart large object spaces on the primary. And the backup on the primary will capture all of that information because it's capturing all the used pages. Even if the slob space is not logged, within the HA cluster and the HA cluster only, the objects are actually logged and sent to the secondaries as part of the transaction commit. That's what allows us to fail over from a primary to a secondary and still have all of your non-logged slobs within that secondary. You can have non-logged databases or raw tables in your primary. Those are not sent to the secondaries, so they don't get replicated, but they do get backed up on the primary because they are used pages, and the backup mechanism on the primary is capturing all used pages. So finally, the last thing in terms of infrastructure is that executing an RS backup will have an impact on the DB space temp parameter that you have set on that secondary. Now, in a properly configured primary instance, you will have your regular DB spaces and at least one temp DB space as well as one temp slob space, and those spaces are obviously listed in onConfig. HA cluster secondaries do not have to have these temp objects. They're not required. Now, in my own personal opinion, I think you need to create them so that your secondaries are exact clones of the primaries for multiple reasons. The most important being is that if you fail over and one of these secondaries becomes the primary, they need to have the same infrastructure as what the original primary had, and that includes the ability to have logged and non-logged temp tables. We'll talk about that in just a moment because there are implications to RS backup on that as well. If you choose to execute an RS backup, whether it's local or cluster, there must be at least one temp DB space properly configured. I strongly recommend that it be a default page size, and these pages or this temp DB space is going to be used to cache modified pages during a backup operation. So let's talk about temporary objects. When you say create temp table, there are two options to the command. You can either just say create temp table and it is created in logging mode, or you can say create temp table with no log, and that is an explicit extra step. We strongly recommend that you use the with no log sequence because it actually creates that temp table in your temp DB spaces. If you simply say create temp table and it's logged, that temp table is created in the root DB space, and that's not a good thing to have happen. Now, trying to create logged temp tables in root DB space is not supported on HA cluster secondaries, and it can become an issue if you're using these secondaries for operations. So we have this temp tab no log parameter, which should be set to 1 on these secondary instances to support your temporary table operations. Now, there is a new enhancement to this parameter, which you'll see in just a second. But currently, this temp tab no log parameter is not really being validated within the instance. The development is aware of this, and they're making some changes to it. But just be aware that even though your temp space is properly configured, you may end up getting -114 ISOM errors from time to time when you are using RS secondaries for updates. So what's the change to this parameter? If a secondary transfers over and becomes the new primary, that temp table no log is still trying to force all temp tables to be non-logged, which could break some of your application syntax. For example, if you simply say create temp table, it's going to try and create a logged temp table, and it's not going to work. So there's now a flag 2, which will dynamically modify the process of creating temp tables to match the state of that instance. If it's a secondary instance, they'll be created one way. If it becomes a primary, it will change the way the temp tables are created. What does backup from an RS secondary look like? Here is my HA cluster. I have 5 nodes configured, instance 1 through 5. Instance 5, by the way, is an RS secondary with delayed apply, and it is turned off for the purposes of this example. Instance 4 is my RS secondary. So you can see that it's up, it's alive, the cluster is synced, everything is working as you would expect it to. The first thing I'm going to do is a local mode backup from instance 4. So on my RS secondary, ltape dev is set to dev null, barsec allow backup is set to 1, and I restart the instance. And you can see the parameters here. I check the backup timestamps by doing an onCheck -PR in both instances, and you'll notice that the last backup for these instances was around 5:36 in the evening. I try and execute an on-tape backup, and it fails. I'm left to ponder why. I have this -803380, which says a checkpoint couldn't be completed. This doesn't give me any information. It doesn't help me understand what's going on. So what you need to do is look at the instance log itself, and you get an intuitive message which helps you solve the problem. The problem is I have at least one, and in my case, I have 2 non-logged slob spaces in the instance. And you'll remember that that is one of the qualifiers. You can't have non-logged slob spaces for an RS backup. I need to get rid of these or change these slob spaces. So I go through, I drop them. Since the slob spaces are smart objects, I need to do a backup. So I just do a fake archive through the sysadmin API. And you can see now that the backup timestamp for both instances is the same, about 6:39, 6:40 in the evening. I then attempt the on-tape backup from the RS secondary, and it executes successfully. Logical log 19 is the active log, but when you look at the onCheck -PR now, notice that the timestamps for the backups are different. On the primary, it's still 1839:31, but on the secondary, it's 1842:45. Why is that? It reflects when that server's pages were backed up. Just to verify that the utility doesn't matter, I also do an on-bar backup using the primary storage manager. The backup on the RS secondary, the backup timestamp on the secondary reflects when its pages were backed up. Just to test the non-log restriction, I create a raw table in my instance, and I try and do another on-tape backup. You'll see that it fails with that 83380 error, but in checking the instance log, it tells you, hey, you've got a raw table, and that raw table is preventing the backup. So the errors in the instance log are the key to solving any problem you have with RS backups. So that's backup in local mode. Let's look at the implications on cluster mode. On the primary, I change ltape dev now to dev null. I set barsec allow backup to 2 and ltape dev to a valid value on instance 4, and I restart instance 4. I check my timestamps for backups on both the primary and the RS secondary, and you can see that they're the same at about 2 minutes after 1 in the afternoon. I do both an on-tape and an on-bar backup. Both of them execute successfully. However, again, the reserve page timestamps are not synchronized after either operation. Why is that? Because we're reporting when the RS secondary pages were backed up. What about the logical logs? With the primary ltape dev set to dev null and rs sekallow backup set to 2 with the rs ltape dev set to a valid value, it appears as though the logical logs are the same. The primary shows them all backed up. The rs secondary shows at least what the current logical log is and when the last checkpoint occurred. I roll some of the logical logs by doing some explicit checkpoints and the onMode command that says roll the logical logs. On the primary, it sees them as used and backed up, but on the secondary, it just shows them as used but not backed up. Why is that? Well, I changed the ltape dev, but I didn't enable backups of the logical log on that rs secondary. So in this particular case, I use an onTape -C, and it automatically backs up all the used logical logs. And now when I look at an onstat -L, you'll see that the rs secondary not only sees them as used, but now backed up. So just because you set ltape dev on the secondary isn't everything you need to do. You also need to configure the backup mechanism for logical logs. So now activity occurs on the primary. In this particular case, I created the stores database in logged mode using the DB access demo. And it went through and created all the tables and loaded them with data and so forth. And when you look on the primary, you can see that there were a number of logical logs that are used, and it shows them as backed up. On the secondary, the full logical logs triggered the backup mechanism, and so they got backed up on the rs secondary. So what about onbar? What are the nuances to using onbar in cluster mode? Well, this is where it gets kind of exciting and fun. If you have bar-sekallow backup to 2 and you execute a backup on the rs secondary, sysutils on the primary and the rs secondary are updated as expected. So you will see that the backup information is available there for you to use. And this is why it's critical that if you set this parameter to 2, you don't do onbar backups on both nodes. Just pick one and stick with it. If you have bar-sekallow backup set to 1 for local mode and you execute a backup on the rs secondary, the sysutils database is not updated, but the IXBAR file on the rs secondary is. So you can see the original set of backup information from 3:51 in the afternoon when it was set to 2. Now I've changed it back to 1. I do a local backup, and you can see the IXBAR file is now picking up that activity at 15:55. This has some restore implications if you choose to restore from an onbar backup. So let's look at what those implications are. Can you restore from a backup created on an rs secondary? Absolutely. Can you restore it to a primary? Absolutely. Can you use it to create an HDR secondary, for example? Absolutely. Can you create another rs secondary? Absolutely. Can you create a standalone node? Absolutely. But whether you use onbar or ontape will affect this restore process. So if you're using ontape, you simply need to copy the instance and logical log backups over to the target server. If you're using the IFX ontape file prefix utility, you may need to rename those files. And once they're renamed to match whatever the target is, you can execute a full restore to create a standalone instance or an instance to participate in an ER cluster. Once that's restored, you will have to do a CDR sync to make sure that that node is up to date with the rest of the cluster. If you intend to create an additional node to an HA cluster, you can use this backup to create or to execute a physical restore with an ontape -PHY. And then when you use the onMode linking command to link it into the cluster, the logical log roll forward operation will occur and will bring that node up to sync with current state. That assumes that the logs on the primary haven't rolled. For onbar, the process is a little bit more complicated. And it's complicated because you can execute the backups either in local mode or in cluster mode, and it affects what sysutils has available for it to work with. If you execute in cluster mode, sysutils is synchronized across the cluster. That's good. But you may and probably will have to copy the IXBAR file to the target server for a cold restore. You may also have to update the storage manager so that it can use the backup objects from the RS secondary to restore to your new target node. So those are some of the nuances for a cluster mode restore. If you're trying to restore a backup created in local mode, you will definitely have to move the IXBAR file to the target server. And if the instance is partially available, you'll need to execute the onFMSync utility to grab the information out of that IXBAR file and populate the sysutils database so that you can complete the restore. Now, if you're doing a cold restore, you can just use the IXBAR file directly. And again, you may or may not need to update the metadata on the objects in the storage manager to restore them to a different target than where they were created from. With access to the backup objects and either an updated sysutils database or an IXBAR file, you can execute either a cold or warm or partial restore as allowed by OnBar. That is everything I have on RS backups, and that is everything we have in XC6. Yes, bar cyclo backup is not documented. It's not part of the online documentation yet, and that is known. Is there anything around using IFX clone and having the RSS as the source to create another RS instance? That is not allowed at this moment in time. The IFX clone pulls from the primary and not from the secondary. I'm not sure where that fits in the prioritization queue for v.next. Problem is IFX clone can create multiple different types of targets, whereas RS backup is intended to just clone an additional node inside of an HA cluster. So there might be additional functional nuances if we allowed that to happen. Any performance impact on the primary during the backup from RS secondary? Absolutely not. The primary will continue chugging along just like it always does. Any overhead from the backup is being absorbed by the RS secondary. There's no impact to the primary whatsoever. Now that said, there are always corner cases where if you're processing 10 billion transactions a second on your primary, the RS secondary may be struggling to keep up a little bit. But within general acceptable usage, there will be no impact on the primary from backup on the RS secondary.